Welcome back. Today we're going to be talking about a new topic called algebraic techniques. So in the last lesson, you were talking about like terms, which are basically terms that have the exact same letter and exponents, such as like the 2 in x squared, right? So in this case, if we were to formally write the definition, it's terms whose letters, which is pronumerals, such as x and y, with any exponents, which is the powers, such as the 2 in x squared, are the exact same. Okay, those are like terms. Now, in this lesson, what we're going to be doing is adding and subtracting those terms. To add and subtract, we need to figure out a rule. In algebra, for you to add or subtract something, they must be in like terms. You can only add or subtract when the terms are like, when they're exactly the same in terms of its letter and its power or exponent. Okay, so in this case, let's just look back on primary school when you did algebra. Right, in primary school, you would have something like this, where it's a scenario in a case of, let's say, I'm going to have people over to my house, right? So I'm going to go to the shops. I thought that I needed to buy 4 apples. So in my first shopping trip, I bought 4 apples, just like this picture here. Okay, so I bought 4 apples, but then short noticed, 2 more people has come over. So what I needed to go and do is go to the shops again in my second trip and pick up 2 more apples. So that's what's happening. I pick up 2 apples, 2 extra apples. I come back home. And when I come back home, I realize that another person has come over and I don't have enough apples. So I will go back to the shops in my third trip, grab 1 apple, okay, and then come back home, right? Now I need to figure out, well, how many apples do I have altogether? Rather than counting all these apples, let's think about it in words first, right? Because we need to think about it in algebra right after. So in my first trips, I bought 4 apples. So I'll write down 4 apples. I need to figure out how many apples I needed to buy, right? And if I figure out that, then that's how many people there are, right? So in the first trip, I bought 4 apples. In the second trip, I bought 2 apples. In the third trip, I bought 1 apple, right? So that is how I would represent my answer. Now, if I had to figure out what would be the total, 4 apples plus 2 apples plus 1 apple should be 7 apples. Now, in algebra, right, what would happen is I like to short things down, right? Mathematicians really like to shorten things down because it makes it easier for us. And for the sake of it, we're just lazy. Yeah, that's basically the reason. So what we're going to do is, using the word sentence that we wrote in words right at the top here, I'm going to say that apples should be represented by the letter A. So anytime I see apples, I'm going to represent it with the letter A. So in this case, for me to rewrite this worded sentence, I would write down 4. Wherever I see apples, I'll just replace it with A, plus 2A plus 1A. Right, now I will do it the exact same. Are these like terms? Meaning, are they the exact same letter? And do they have the exact same power or exponent? In this case, lucky for me, they're the exact same letter, tick, and they're the exact same power. In this letter A, there is actually a power of an invisible 1, right? So that means they are like terms. And because they're all like terms, I can add them all together. So 4A plus 2A plus 1A should get me to 7A. Is that correct from when I use my word problems? Yes, it was. Okay, so that's how I figured it out in algebra way. Let's do the question 2. a little bit more faster, right? Same deal. In this case, I got 5 apples in my first trip. Then what happened is I bought 3 blueberries in my second trip, and in my last trip, I bought 2 apples. So let's write it in words. I got 5 apples plus 3 blueberries plus 2 apples. This should total up to, it actually won't total up to 10, but it would actually total up to 7 apples plus 3 blueberries. Right. Reason being is apples and blueberries, they're different things, right? So they can't be counted as one. So blueberries cannot be counted as apples, and apples can't be counted as blueberries. So I have to leave the blueberries by itself. So I've got 7 apples and I've got 3 blueberries. Okay, so it's a little bit more different compared to our example before. Let's say, again, I'm going to represent apples as the letter A, and I'm going to represent blueberries, as you guessed it, the letter B. Okay, so I'm going to rewrite it. I've got 5 apples, which is 5A, plus 3 blueberries, which is 3B, plus 2A, which represents by 2 apples. All right, so in this case, one strategy for you to do is, well, figure out where your like terms are. When you figure out your like terms, when the items or the letters and its power are exactly the same, circle it, square it, highlight it, whatever you would like. Okay, so in this case, 5A and 2A, they are the exact same letter and the exact same power. So I'm going to box it. Now, I'm not just going to box just 2A, I'm going to box it with the plus. So any sign in front of that letter or that term, I'm going to take it with me. Okay, so I'm going to box 5A and box plus 2A. And now what I'm going to do is I'm going to circle, not 3B, but I'm going to circle plus 3B. All right, so let's rewrite it. Let's collect all the A's on A's together. So I've got 5A plus 2A, right? And then leave the plus 3B at the end. Now, after I've done that, let's just add this like terms that I can. So the only like terms I have is 5A plus 2A, which gets me to 7A, plus 3B. 3B needs to be left alone. There's nothing else. There's no other B's. Okay, so my answer is 7A plus 3B. All right. I might separate this into the part 2. So I'll stop here and watch for part 2. See ya. Bye.